welcome to the lecture, I don't know, 6 or 7. Basically, second lecture in practice. हमने last time किस चीज़ की practice की थी? Basic probabilities, right? So we assigned, we defined sample spaces, yes, and we assigned probabilities to those. We looked at conditional probability, joint probability. हमने कुछ examples कर रहे थे, right? And I remember the last problem we did was regarding total probability. So let's see what's yeah. So this was the last problem we did. Yes. Yes. So what was it about? A bag contains 4 white balls and 3 black balls, and a second bag contains 3 white balls and 5 black balls. One ball is drawn from the first bag and placed unseen. So आपको पता नहीं आपने वो से उठा के रखी है, right? In the second bag. What is the probability that a ball now drawn from the second bag is black? So what did I say was the first step when you start attempting these kinds of problems? क्या था पहला step probability में? मतलब एक्सपेरिमेंट को तो आपने समझना है अच्छी तरह, राइट? वो तो हो गया, कॉम्प्रीहेंशन तो की है. इफ अगर आपको समझ ना आए कि हुआ कहा क्या है इन्होंने, फिर तो सब कुछ गलत हो जाएगा, राइट? नाउ वंस यू हैव कॉम्प्रीहेंडेड व्हाट दे आर सेइंग, पहला स्टेप क्या है, क्या डिफाइन करना है? इवेंट्स. Okay, so sometimes we do the sample space first, but anyway sample space and events. Yeah, so इस case में let's see what are the events that we are interested in. Yeah, so we saw last time that defining events can also be done in a subscriptive way. So you can say, okay, I will define an event B1, meaning what? That the first ball drawn was black. So 1 क्या represent कर रहा है उसमें? First ball. Yeah. So you can define events in any way you like. It's fixed नहीं, it has to be a letter. It has to have one subscript. 4 subscript, superscript भी आना शुरू हो जाएंगे, right? Depending on what the problem requires. इससे पहले problems easy थे, you didn't need a subscript. Now you need it क्योंकि दो sequential काम हो रहा है ना. You take from one bag and you put in the other bag. So you need to identify, okay, what happened in the first bag when you put a ball out without seeing what happened there. So क्या हो सकता है? दो ही possibilities हैं, B1 or W1. पहले bag. Yes, you could have either drawn a black ball or a white ball. Right. What about the second bag? उसमें क्या क्या possibilities हैं? Again, 2 possibilities. Yes. तो आप निकालते हैं, you draw from it. It could be a black ball or a white ball. So to distinguish it from the first event, in the sequence we give it the subscript 2. Yeah. So you can call it B2 and W2. It's not unique. आप कुछ और भी बना सकते हैं, but this seems to be the very common and most say succinct, best way है ये mostly. So now the question is, after you have defined your events, then you try to put whatever the questions are, whatever the information is, in terms of those events. Yes? So, what is the probability that a ball now drawn from the second bag is black? Yeah. So, if I wanted to write the question in terms of the events we just defined, 4 event defined किए ना, B1, B2, W1, W2. So what is the question in terms of one of those events? Yeah, more of those events. कैसे लिखेंगे? Equation लिखनी है. Yeah. So then we write the question in terms of the events. What is the probability that a ball now drawn from the second bag is black? So what are we asking for? What are we looking for? Probability of B2, right? यही मांगे गए ना? So let's erase this. This is what we have been asked for, right? Now here the information जो हमारे पास है, based on that you will try different things, but you realize okay, it's not so straightforward to answer this question. So we will go towards total probability concept, right? And what does that say? What are the two possible ways that you can draw black ball in the from the second bag, right? So कैसे आएंगे? Either one way is that you had drawn first bag से आपने black निकाली, right? And second bag से आपने black निकाली. दूसरी possibility क्या है? White निकाली and is there a third possibility? No, right? किस केस में? Yes, हो सकती है, but relevant to this thing, you are interested in what? That the second ball is black. Yes, दूसरी white हो सकती है, but that possibility you are not interested in right now, right? So as far as this possibility goes, it could have happened in only two ways. Yes, क्या मतलब हम कह रहे हैं कि the first one, irrespective of what happened in the first one, you could have got the black ball. Yeah. So what could have happened in the first event? V1 and W1. Yeah. So now are these mutually exclusive? पहले जो events हैं V1 and W1 है ये mutually exclusive या नहीं? Yes. They are. Yes. It couldn't be that they both hold at the same time. Either you could have drawn a black ball in the first from the first bag or a white ball. So they are mutually exclusive. Do they span the sample space of the first bag? Yes. That is all you could have done. कोई yellow ball तो नहीं आनी इसमें से. So this satisfies both conditions of total probability. Okay. When it does that, we are normally able to say okay. Even without knowing the formula, you can simply say that probability B2 has to be probability B1 and B2 plus probability W1 and B2. So the only two ways that you could have drawn a black ball from the second ball is either this or this. और दोनों mutually exclusive है, so you can simply plus. You don't need a minus here, a third term, right? We don't need that. So from here, what can we do now? Further हम क्या करते हैं? Total probability में we replace these by conditional probability, right? So what would be a conditional probability that would make sense here? First term के लिए probability. Firstly, you remember the formula for conditional probability. Probability A given B is what? A and B divided by probability of B. Yes. Now, given that BB is not 0, that's accepted. So in this case, if I treat, let's say, B2 as A here, how would you write it? When I write it like this, you could bring this here. So probability B1 and B2, I could write it as probability of drawing B2 given that the first ball was B1 times probability of B1. Yes, formula को सिर्फ हमने shift कर दी. So this is all there in the total probability formula. I'm just redoing the formula also, so it sticks in your mind that it makes perfect sense. Now, same thing you can do with this one, right? How would you write it? Probability drawing B2 given that the first one was white, W1 times probability W1. But now by doing that, you have made your job easier, because now you can easily calculate these guys from the given information. For example, what's the probability of drawing a black ball from the first bag? Easy है ना ये तो? क्या probability है based on this information? 3/7. Yes, because 4 white and 3 black balls. So what's the probability that when you draw a ball randomly, you get a black ball? 3/7. 3/7, because 4, 7 total balls, 3 of them are black. Now, this is so easy to calculate, isn't it? Yeah. What about this one? Is this also easy to calculate? इससे पहले answering this would seem very hard, but once you break it into various terms of conditional probability using the rules of total probability, you can easily calculate all the components. So, कोई ये बता सकता है इसकी वैल्यू क्या? Now, what is the assumption here? Given that the first ball that you drew was black, and since the experiment says that you're going to put it in the second bag, yes? Now, given that that has happened and you know that the first ball was black, with that information, what is the probability of drawing a black ball from the second bag? 6 by. So how many balls in the second bag in total now?
9 total balls.
8 plus 1, 9. Yes? How many of them are black? 6. Yes? Now 6 balls are black, so 6 out of 9. So see, each component is so easy to calculate from this information, isn't it? But directly calculating this, it's very hard to imagine how would you go around doing it. Yeah? But once you split it, it becomes very simple. This was very simple. I think even a child can answer क्या probability होगी. This is so simple. Once you assume कि जो आपने रखी थी वो black, so you get this term, put it here. बता दिया ना आपने number दोनों. You put them here. What about this guy? Same procedure. Yes. So you will have probability black ball given that the first one was white times probability of W1. And it's very easy to do that, just like you did that, and you can put those here. That's what's going to happen. So the moral of the story or the lesson here is what? That often the probabilities we are looking for are not very apparent from the problem statement or the information we have in real world. But often we can break the required probability into its parts. Yes? And then we can sum those parts. And usually that approach of doing that using mutually exclusive parts is called total probability. And you have the formula in the book, but for this kind of problem you don't even need the formula. You just with practice you understand that it makes sense. Okay, let's see now. I'll let you read it and get an idea of what it is that is required. So there is an electrical system here, yes, different components and these numbers show the probability that they will work. Yes. So the reliability of each component is shown in this figure. So 90% of the time this works fine, 90%, so on. Yeah. Find the probability. There are two parts here. First, the entire system works. Let's start with that. Okay. And what's the requirement for a system to work? The system works if components A and B work and either of the components C or D work. Right? So again, do we start with events? Yes? In this case, it's easy to say that let's define an event A, which means that A is working. So you don't need to define a new variable, new letter. Yeah, just use it. So you say, I'm going to say, okay, A means that component A is working. B means component B is working. Then A complement would mean component A is not working. Yeah, so on. So in that case, first, can you tell me what is required in terms of sets? Can you tell me what is required for for the system to work? A and B work, and either of component C or D work. Yes, so how should I write it? Yes, some of you started that. A and B or B? A and B with what?
C or D.
So it has to be A and B. A and B with another end with C or D. So three components have to work. Yeah. We have no choice in A and B. They have to work. ये लिखा हुआ है. But we have a choice among these. But one of them has to work. So three components have to work, C or D. So that is when they say, okay, what is the probability that the entire system works? What are they asking for? Probability of what? This thing. Right? Okay. So can you quickly calculate it and tell me what number you get? Let's assume that the four components work independently. इसका फायदा कहाँ आएगा? You remember this independence condition? We had seen that if two events A and B are independent, then their joint probability can be written as a simple product. Otherwise, ऐसा कोई formula नहीं है. Yeah, otherwise you usually have to do conditional or do something else. But if they are independent, this becomes very simple and it doesn't just apply to two variables. It can be 3, 4, any number. So here you have a bigger set. But try to find. You have the numbers, you have the probability formulation in terms of events. So try to find the answer to A. 1.3. आगे? 1.3. Okay, let's check. मुझे याद नहीं है वैसे देखना पड़ेगा. So okay, let's keep that, and before I show you the solution, because it has part B also, so I want you to think about formulating part B. ठीक है? Part A तो मैंने formulate कर दिया था आपको. यार B क्या कह रहा है? Can anybody explain? The component C does not work given that the entire system works.
So what's the next step?
कौन से minus कर देंगे? So C does not work. So what is given here? Entire system works. Yes? And if the entire system is working and C does not work, then D must be working. So think about how you would formulate this thing. अच्छा, many of the probability जो इस तरह they don't always have one way of doing it. Okay, someone would do with a complement, someone will have a more brute force approach. But with practice, you get better at it. So let's go there. A तो हो गया. Any problems with that? Okay. As I said, there are multiple ways of doing all that, but once you have formulated, you can use whatever information you have to try to solve this. Yeah. So this was part A. Part B.
Parting something here.
ये तो हमने लिखा था.
Yes, sir.
अब इसको expand करें.
Complement करो, yes, sir. Complement.
You could replace it by it's just saying 1 minus 0.8. Yes. So you could do directly if you have access to that information.
So the self pointed market से multiply करेंगे.
यहाँ से करेंगे. How do you solve this? Start by this. Probability C union D. है आपके पास? नहीं है. Problem वहाँ से शुरू होती है. But this is not the only way. You could have done it in some other ways. You could try to do like probability C union D is probability C plus probability minus probability C and D. Right? So if you have that information, you can try to work with that. So it's not like they just directly saw this. Yeah. When you are doing it, एक दो आप tries करेंगे. What's the indicator that you're in the wrong direction? जब आपकी जो आ रही हैं उसकी values ना हो आपके पास, right? That means okay. Yeah, theoretically you're right. You could write it like that. But the way the problem is formulated, or the way the real problem you're facing, the data you have is not going to work here. So then you do what? Juggling करते हैं आप. Yes. Then you juggle and you find, okay, if I can't do that, I can have something else. Right. So this is the conditional probability in this case. Basically is that probability the system works but C does not work, divided by the probability that system works. Okay, this is C does not work, meaning C complement, given the system works. Yeah. So as I said, C will be complemented. The only way the system will work, D complement cannot be here. Yes. Why can it not be here? To given out information. वो क्या है? That the system works. Now you want to find the probability that C does not work. Well, if the system is working and C wasn't working, there's only one way is A, B and D had to be working. वरना system भी fail हो चुका. So this is what's done here, and you get the whatever you calculate. So try it. These are in your book, these examples. Okay. So go through them again. Try to solve them again. Maybe you can do it in a different way, and I can tell you, I can assure you, this is not the only way to do this. Okay. So try it if you come up with a different way, but the same answer may be correct also. Okay. Again, in probability theory, problem statements are pretty long, so take your time to fully comprehend the experiment. Yes? ये क्या है experiment? 3 analytical plans for design and development of a particular product. Cost, reason, all 3 are used at varying times. Plan 1, 2, 3 are used for 30, 20, 50 products. Effect rate is different for the 3 procedures as follows. First you have to understand what it's saying. So क्या है ये? You can make something, let's say this nice, yes, product है. There are 3 different ways of making it. Yeah, and we'll call them plan 1, 2 and 3. Effective होने की probability क्या है? Firstly, the company produces 30% of its products using plan 1, 20% of the products and so on. The defect rate, what does this read? कोई पढ़ सकता है इसलिए क्या करें?
Effective given P1 or span or source second.
So पहले प्लान से अगर आप प्रोड्यूस करें तो डिफेक्टिव होने के चांसेस क्या होते हैं 0.01. Yes, what does it say? It's saying basically that 1% of products made by plan 1 are defective. ये क्या है? Yes, so probability of having a defective product given that it was produced by plan 1 is this and so on. So you have these three probabilities. Basically it's telling you what percentage of the products given by each plan are defective, right? That's all it's telling you. So question kya? If a random product was observed and found to be defective, which plan was most likely used? So now आप buyer है, yeah? You don't know which plan they used. You just bought this product and you find that it's defective. Yeah? So which plan was most likely used? अब ये सवाल क्या है, किस तरह क्वेश्चन को अगर आपने इसको लिखना हो, इन probabilities क्या होगा?
सर सारों का डिफेक्टिव से मतलब वो निकालेंगे और कंपेयर करेंगे जिसका जैसा
राइट, सारों का निकालेंगे. सारों का कैसे निकालेंगे? P की फॉर्म में लिखना है, ठीक है? ये वाला राइट डायरेक्शन. So let's say किसी एक प्लांट का मैंने क्या चीज है आप that is the key. अगर वो आप ठीक लिख लेना तो आगे फिर आप करते जाएंगे.
probability of given defective.
Exactly. तो ये क्या हमें करना है, इसको उल्टा देना होता है. इसलिए अक्सर statistics is available in one form and the inference, the conclusion you want to draw is usually reverse form. So इसलिए these kind of formulations come in handy. So we are asking what's the probability that plant 1 made this product, plant 1 made this product given that it is defective. Why is that given? Problem to work. If a random product were found to be defective, yes, that's where the given D comes in. Yeah, so your friend is right. ये आप किसके लिए करेंगे? तीनों के लिए. And then you will see, okay, max किसका आता है? Yes, so you will do this for P2 given D, P3 given D. What's the probability that the third plan was used given that it is defective? So now ये तो आपको clear है इसमें? Yes, you wrote the right question. Yeah. Now after that, if you try to solve, you realize that answering that directly may be hard. Okay, you will not start here. Yeah. Often you will start with what you know. What do you know? You know that usually you will start by saying, okay, probability P1 given D is probability P1 and D divided by probability of D. Yes? But what did I say? What's the indication that you are not there yet or going in the wrong direction or you need to change the formula? When you are unable to find now values. So do you have P1 and D? Problem is that given in here. Yes? It's not there. अगर होता तो you don't need to do this big thing. Yeah? Okay? Basically, you could have done this thing. But since it's not there, you will have to then work with it. Yeah? And basically they are using the idea of total probability and Bayes theorem along with total probability. Okay? Bayes theorem yaad hai aapko? So one interpretation that we discussed for Bayes theorem was that if you know the probability of A prior, posterior हमने किया था, and now you want to do, okay, I want to update the probability of A given new information which is B. So इसको हमने कहा था posterior. Other probabilities we have discussed with total conditional joint posterior. So probability A given B was probability B given A times probability A divided by probability B. Yes, this is what's being used here, because we can see, okay, probability P1 given D, the direct formula doesn't help us because we don't have this information. So what we will do is we will split the two terms into what information we have. And firstly, we do this. You will probably try this, not working, then you will go to, okay, there is this base formula. If you don't remember base formula, it's fine. You can just replace this by what? So probability P1 and D, this one, you can simply replace it by the conditional formula. Conditional formula, this same formula we use it in many ways, right? So you will replace it by that, and this is what it comes out to be. What will you do with PD? यहाँ क्या use हुआ है? Total probability. You're not interested in this thing, but you don't have PD. Yes? To solve this problem, you realize I need PD. Now then you have to work with or think about, bring about your knowledge in use here and see, okay, how can things be defective? तीन ही possibilities हैं, ऐसे ही है ना? कैसे हो सकती है defective? Again, it can be defective if defective and produced by plan 1, ऐसे, or defective and produced by plan 2, or defective and produced by plan 3. अब ये exactly वही जो मैंने पिछले problem में किया. Just there are 3 terms there, we had 2 terms. You can, of course, before applying this total probability, always make sure what these are mutually exclusive. One thing. Second, they span the sample space, right? So they should cover all the possibilities. Do they cover all the possibilities? अगर उस कंपनी ने बनाया है तो इनमें से एक ही प्लान यूज किया होगा, चौथा तो था ही नहीं कोई, right? So they covered all the possibilities and they are mutually exclusive. Once you satisfy that, it's only a matter of writing out the total probability rules. Again, अगर आपको याद नहीं है, it's perfectly fine. Just apply. बार-बार ये formula use होता है असल में. This is the formula we are using again and again. Probability A given B is probability A and B divided by probability B. Right? तो इसके बाद हम करते क्या है? Basically, we just change that to say, okay, then what would be probability B given A? It would be probability A and B divided by probability A, and then we send this guy here. Yeah, बस ये बार-बार हम करते हैं. So it's actually this formula that is being used again and again. If you want to memorize total probability formula or Bayes theorem, it's fine. थोड़ा shorter हो जाएगा. But एक दो और step लगेंगे, भूल जाएं, no problem. You should have enough understanding of probability to split the problem into this. And unlike the solutions in the book, you are allowed to stumble a bit, right? लेकिन exams times क्यों होते हैं? Why don't we give you all day? क्या check करना? Let's say आपने ये furniture बनवाना है टोपी से, ये टेबल बनवाना है, yes? बड़ा अच्छा कारपेंटर है, वो कहता है मुझे साल लगेगा. It's no use, right? So an expert in their field doesn't have to just answer the thing or do the thing. They have to do it well and do it efficiently. जब efficiently करते हैं तो time पे होती है, right? So we give you timed exams. to make sure that you have practiced so much कि आप बार बार stumble ना करें, थोड़ा सा करें, लेकिन अगर आप पूरे एग्जाम में इसी को लेके घुमाते रहे, कभी ये डालते हैं कभी वो डालते हैं, एक ही सवाल पे 1.5 घंटा खत्म हो जाता है, that means you haven't practiced enough. आपने वो स्किल, उसका जो नॉलेज है वो सारा इतनी ज़्यादा स्ट्रेंथ के साथ या फुल ग्रास्प उसको आपने नहीं किया. Often students say that I knew the solution but I did a blunder, right? और आप नोट करेंगे कि आपकी जितनी प्रैक्टिस तो जो कम हो उतने ब्लंडर्स बढ़ते जाते हैं. So it's not really a blunder that you do, right? मैं सही जा रहा था बस एक ब्लंडर हो जाता है, लेकिन most cases why that happens, lack of practice. Yeah. So after a few trials you should get here. It's not that पहला ही आप पाओगे, लेकिन अगर आपके 10 ट्रायल्स के बाद भी आप यहाँ नहीं पहुँच रहे हैं तो टाइम तो लगेगा एग्जाम का. Yeah, so please practice sufficient amount of problems and see that you are getting better at it or not. फिर देखें कि क्या चीज़ मिसिंग है, what is the knowledge or information that is missing that's keeping you from doing that. इसमें कोई है सवाल इस प्रॉब्लम? So again we just keep playing with the total probability formula. You already told me that this is what you have to calculate. Most likely your first guess will be to try this, which would be the right guess because यही है पहला simplest formula. But then you realize I don't have this, I don't have this. What do I do now? वहाँ फिर आप अपना tool box जो knowledge का है उसको use करो. Mostly we don't make you do new research in exams or the course, right? So ऐसा नहीं कि आप इसको करने के लिए जो अगला स्टेप चाहिए बेस थ्योरम, तो इसको करने के लिए जो टोटल प्रोबेबिलिटी थ्योरम चाहिए पढ़ा दिया ना आप, यू हैव दैट, सो इट्स इन योर टूल बॉक्स. यस, अब आपको उसकी इजी एक्सेस होनी चाहिए. अगर इजी एक्सेस आपके पास नहीं है, मैं मेमोरी की बात नहीं कर रहा, आई एम टॉकिंग अबाउट योर ब्रेन लिंकिंग this kind of problems to total probability, to base problem, base theorem, right? So that link will become strong with practice. Okay, so please इसको आप जरूर इन problems को करें. Okay, sometimes we like to ask you simple questions. This is one of those types. What's given? क्या बताया गया? Experiment नहीं बताया गया. You don't know, right? So analytically, when you want to study something analytically, maybe you don't even know where this is coming from, right? But you have to stay within this thing. So there is an experiment. Okay, you are told that it has how many possible outcomes? 5. A0 to A4. They are mutually exclusive. Yes. Are they equally likely? What do you think? नहीं है ना, so don't assume it. Okay, आप में से बहुत से लोग assume कर लेते हैं. It has to be given or it has to be justified from the experiment. Yes, if I roll a die, I don't have to tell you. I just say fair die. You know that equally likely. 1 to 6 are equally likely. Here, हमें पता भी नहीं experiment क्या है. So whatever is given, that is what we can work with. It doesn't say they are equally likely. It does say they are mutually exclusive and that they are the only possibilities. That's what it's saying, right? So what's the sample space? S, A0, A1, A2, A3, A4. Okay. Now you're given the probability of A0 union A1. Okay. You have to say, okay, which are true and which are false, and you have to give reason for it. So you can start. पहले का क्या कहते हैं? S bar है ना? Zero होना चाहिए, right? Why is it 0? Because what is S bar? That's S. That's what is S bar?
S bar
Complement of S. S minus S. तो null हो गया. Empty set हो गया. Empty set की probability 0 होती है. So you're right. So that should be your justification. You can show that this is S minus S. S minus S is a null set. Null has 0 elements, so its probability has to be 0. So 0.1 नहीं हो सकती, right? Second, false है, easy है. Why? Probability can be negative. Third one. Here interesting approach. Remember, justify people. Yeah. इस तरह क्वेश्चन में आपने से अक्सर लोग ना बस ट्रू फॉर लिख देते हैं. उसका सोर्स भी अक्सर इधर उधर से ही होता है. राइट, यू हैव टू जस्टिफाई और यू गेट नथिंग, क्योंकि वैसे तो वो आपका दोस्त इशारा कर देता है ना. सो लेकिन जस्टिफिकेशन का इशारा थोड़ा सा मुश्किल होता है unless आपने कोई स्पेशल साइन लैंग्वेज सीखी. राइट, सो व्हाट्स द पार्ट सी? फॉल्स. जस्टिफाई.
यूनियन की प्रोबेबिलिटी गिवन.
यस.
A1 की 0 से तो ज़्यादा ही होगी.
0 से ज़्यादा है.
0.4 से ज़्यादा है.
हाँ. So we know probability A union B is probability A plus probability B minus probability A intersection B. Yeah. Now in this case they are mutually exclusive, so this disappears. The sum of the two probabilities, which have to be, each one has to be non-negative, the important है, right, is given. What is that? 0.4. जब दो terms हैं, दोनों positive हैं और उनका sum 0.4 है, तो फिर उनमें से कोई अकेली term तो उससे ऊपर नहीं जा सकती. Maximum यही हो सकता है कि एक 0 और दूसरी 0.4 हो. Right? They have to sum to 0.4, keeping both positive. Yeah. So definitely 0.46 is impossible. And you will use this justification. Yeah. Okay. What about this? False. Easy. कुछ भी गलत करने की जरूरत नहीं है. Probability cannot be more than 1. Although बाज़ का लोग कहते हैं मुझे 200% sure है. Right? बोलने की हद तक ठीक है. We don't allow it here. अच्छा. What about the fifth one? False है.
0.6.
Reason?
जो कि C के लिए हमारे पास
क्यों? C का और केस था, वहाँ यूनियन थी. यहाँ तो SP है, इंटरसेक्शन भी है. It's not that simple.
सर 0.4 के साथ कैसे थे कुछ मल्टीप्लाई हो रहा है क्योंकि यूनिवर्सल सेट है तो या तो कम होना चाहिए या ज़्यादा और ये चेंज नहीं हो रहा.
मल्टीप्लाई नहीं हो रहा है, सेट ऑपरेशन.
इंटरसेक्शन
सेट ऑपरेशन करें अपने ज़हन
सर
में.
क्यों नहीं होता क्योंकि A यूनियन A1 हमारे पास 0.4 है और वो पूरे सेट के अंदर से कॉमन क्या आता है 0.4 ही.
हाँ जी. Anyone else? पहले I can suggest just look at this set first, this whole set. ठीक है. कई तरीके होते हैं ना प्रॉब्लम को टैग करने की. Yes? इस सेट को देखिए. इसको सिंप्लीफाई कर सकते हैं इस सेट को. S intersection A0 union A1 क्या बनेगा? अरे इंटरसेक्शन भूल गए क्या होता है? कॉमन होता है. तो A0 union A1 has to be inside S, right?
Yes sir.
So the intersection will just be A0 union A1 back. वही आ जाएगा.
Yes sir.
Right? S के अंदर वो जो पार्ट है वही तो मुश्तरक है उसके साथ, वही कॉमन है ना, इंटरसेक्ट कर रहा है. तो इट्स एक्चुअली सेइंग प्रोबेबिलिटी A0 यूनियन A1 वो तो आपको गिवन है. Yes? so it is true. ये समझ आया या set operation करके देंगे. S contains this thing. Yes, and now you want to take intersection of S with this thing. फिर उनमें S में और इस चीज़ में common क्या है? यही चीज़ है common, और तो कुछ नहीं. So that is point 4. Yeah.
अगर इंटरसेक्शन की जगह यूनियन हो तो फिर
क्या होता है?
इंटरसेक्शन की जगह अगर यूनियन हो
अब क्या है क्या? डाल सकते हैं आप यूनियन डाल दें अगर S यूनियन करना है ना.
ऐसा
क्या होना चाहिए आपको?
ये तो मैं पूछ रहा हूँ सर,
है?
ये मैं पूछ रहा हूँ सर.
नहीं सही है, मैं समझ गया सवाल. अब आप कुछ सोचे ना, मौका दे रहा हूँ. बहुत इजी जवाब है. यूनिवर्सल सेट के साथ यूनियन करने जा रहे हैं आप, क्या होना चाहिए? खुद आ जाएगा. उसमें मजीद क्या डालेंगे आप? इस प्रॉब्लम का यूनिवर्सल सेट है ना वो, उसमें और तो कुछ नहीं डाल सकते आप, खुद ही आ जाएगा. यू विल बी टॉकिंग अबाउट प्रोबेबिलिटी ऑफ S. व्हाट्स द प्रोबेबिलिटी ऑफ S? नहीं 1
ऐसा 1 स्क्वायर
1 हो जाएगा. सही है.
सही सर.
But good question. So इसका you can play around and try to see what they are. Yeah, so you already answered all those. ये पुराना लिखा हुआ लग रहा है. लैपटॉप कंप्यूटर, वी जस्ट से लैपटॉप्स. शुरू में जब आए होंगे डेस्कटॉप कंप्यूटर. A shipment of 20 similar laptops to a retail outlet containing 3 that are defective. If a school makes a random purchase of 2 of these computers, find the probability distribution for the number of defectives. अभी तक इससे पिछले सारे प्रॉब्लम और मॉड्यूल 1 signing probabilities, right? किया ना हमने sign differently play around. Now we are in module 2 where we talk about the distributions. क्या थी distribution जो हमने की थी? Probability mass function, cumulative distribution function, marginal, conditional, joint, and then for continuous case just the mass function was replaced by density function. Yeah, बाकी सब वही था. So first, is this a problem of discrete random variables or continuous random? Discrete है, right? Okay. Question क्या है? If a school makes a random purchase of 2 of these computers, find the probability distribution for the number of defective. So what's your random variable? Let's call that X. Yes. What's your random variable? It is, let's say, X. That is number of defectives. Yeah. हम बाकी जुमला छोड़ देते हैं अक्सर. Yeah, that doesn't mean number of defectives in any way. It's saying number of defectives given that this setup is accepted. Yeah, what is it saying? That you randomly purchase 2 of those. Yeah, and you know that the shipment had 3 that are defective. Okay, so how do we assign a probability distribution? Yeah, so आपको याद है what was it? This is a discrete case. So if you remember, f of x was what? Probability capital X takes the value small x. Yeah. Now if you can write this formula or values of this for all possible values of x, you got the PDF, probability distribution function. आ गया. Can be some function or it can be just a table, depends on the situation, but ये निकालने को कह रहे हैं. Okay, in this case. So first thing you need to identify again is the sample space. अब sample space आ जाएगा in terms of numbers. अब हम deal कर रहे हैं with numbers. Yeah. So x की क्या values हो सकती हैं? Possible values क्या है small x की? X is number of defectives जो स्कूल ने खरीदे ना, राइट? तो स्कूल ने कितने खरीदे? दो खरीदे yes.
Yes.
So how many of them can be defective? 4. एक और 4 0. So x की फिर कितनी वैल्यूज आ गई? 3 values. 0 1 2. Now if you can find the probability for each value, put that here f0 f1 f2, you got the distribution. क्योंकि बड़ा easy case है कोई. Yes. So I just put this example here to just bring home the idea that for discrete cases often it's not a huge task. It's just finding. So find करें फिर probability f0 mean probability x equals 0. क्या मतलब हुआ? ये जो दो खरीदे हैं उनमें से कोई भी डिफेक्टिव नहीं है, लकी है क्या? 20 में से 3 डिफेक्टिव थे, ये इंफॉर्मेशन आप पास है अलबत्ता. So first you will try to find okay probability x equals 0. This will be our f0, f1 f2. क्या बाकियाँ क्या होंगे सारे? You can still find f5 by the way. क्या जो हम डिफाइन नहीं करते वो क्या होते हैं? सारे 0 होते हैं. So probability of 5 defectives is 0 because the experiment says you only bought 2, so 5 तो defective ही निकल सकते हैं. So हाँ जी करें जल्दी से. probability x equals 0 क्या है? कैसे करेंगे इसको? This takes us back to counting cases. Yes, number of ways things can happen. Okay.
So पहले वाली कैसे थे? 17 by 20 multiplied by 16 by
17 by
20 multiplied by 16 by 20.
so where is that come from? 17 by 20 is 3 by 20.
3 हमारे पास defective है, so 3 minus 20 is 17 ना. 17
Yeah,
by
but
20.
then you would be missing. This is a problem that involves some sort of combinations or permutations. I can give you that hint. Straight नहीं है. क्यों straight नहीं है? देखिए 20 है ना, right? उन 20 में से आपने 2 लिए, ऐसे ही है. So how many ways can you take 2 out of 20 numbers? ये देखना पड़ेगा आपको. So that is one thing you have to see. Okay, how many ways are there that I can take 2 computers out of 20? That is the total possibilities, yes, that you could have taken. Now when x is 0, what happened? आपके साथ क्या हुआ कि आपने जो choose किए हैं, how many ways can you select 0 from the 3 defective and 3 defective, 2 from the 17 undefective, non-defective. Combination को लिखने का तरीका है NCR का ये तरीका लिखने का, right? So we did that combination thing. First thing can happen in this way, is second can happen in this way. ये counting हम कर रहे हैं, right? Total कितने possibilities थी कि how many ways could you, in a computer and beast, you could have picked these 2, you could have picked this and this, you could have, so ये तो फिर काफी बड़ी range है ना, एक एक करके तो नहीं गिनेंगे आप, right? So you have to see, okay, is it a combination problem, is it a permutation problem, is it a powers problem? So in this case, it turns out to be combination problem. Number of ways you can choose 2 computers out of 20. That's the total possibilities. If you are saying that I chose 0 defective, for that what should have happened? Well, you have to see, okay, how many ways you can select none of the defective and 2 of the non-defective, right? So what about, now you can see the second one, probability x equals 1 क्या होगा? f1 ये change होगा?
No.
Denominator?
No.
Right? Numerator will change.
3 1.
You ended up choosing one of the defective ones and one of the good ones, yeah, and so on. So उसकी कैलकुलेशन आप कर लीजिए. So you get f0, f1, f2, right? And this is the probability distribution. Yeah, probability distribution of x. Yeah, so you just assign the function for all possible values of x, and that is your PDF. Now PDFs can be derived in many different ways. For easy cases, this is one way. Discrete cases, and for easy discrete cases, this is one way that you can do it. And वो जो आप कह रहे थे 17 क्या था 3/20, वो that won't work. थोड़ा सा उसको आप अगर imagine करें ना, because you can pick so many ways, so it's a matter of combinations now. Right. Find the cumulative distribution for this example that we just okay, we didn't do that example, but I will do that here. Let's say you are given the probability function, this guy, of a random variable x, and now you are asked to find cumulative, that is capital F(x). Okay, it refers to another example. I took the function you need from there. So this is this a discrete case or a continuous? कौन सा केस है? Discrete है, easy to see because the random variable x takes a discrete set of values 0, 1, 2, 3, 4. Right. So we want you to find capital F of x. कैसे find it? What was capital F of x? याद है? Discrete case में क्या? Firstly, what was it in terms of probability? Cumulative distribution function. Right? What was it? Probability x less or equal. Right? So you're looking for the left hand range. From minus infinity to up to that value of x. So when you say f3, you're saying what's the probability that the random variable takes a value from minus infinity up to 3. Yes? Whereas small fx says f3 says what's the probability that it takes a value 3. It is discrete. For continuous, it just represents the likelihood. So less or equal to x. Now in this problem, this definition is not helpful, is it? At least first part के लिए to find fx, is it helpful? At this point, not really, because you have fx. So what was the definition for discrete case? Remember, it was so to find f3 or f small x, you have to sum all the values of the distribution function fx from left hand side up to that point. Yeah. So इस case में, now again just like we did in the last case, to find the cumulative, since this is an easy case, all you need to do is find f0, f1, f2, f3 and f4. Once you have found those, you have answered this question. You have found the cumulative distribution function. So what is f0 in terms of this? Small f की terms में f0 summation, take all possible values that are less or equal to 0. कितनी है? एक ही बनती है, equal to 0. Yes, जो माइनस वाली है वो तो है नहीं इसमें, so probability there is 0. So this will be f0, and you can calculate it from here. यहाँ आप 0 रखेंगे, yeah, and you will get that. What about this one, f1? So another way of looking at it is saying F0, F1, F2, F3, F4. So F0 is saying sum all the values up to here. Yes, from left to here. Left उसमें है ही नहीं मज़ीद, so you start here. Capital F1 is saying sum all the values up to here. Yes. Capital F2 is saying sum all the values up to F2. So it's very straightforward. Yeah. And it represents the probabilities. So ये क्या होगा F0
plus F1
plus F1. Yes. ये होगा F0 plus F1 plus F2. So you don't have to do it every time. Once you found F0, put that here. Then find F1 from here. Put that here. Like this. And F0 and F1 sum you have. Put F2 here, and so on. Can anybody guess without solving the problem value of F4?
so 1 minus F0
Right. F4 की value क्या होगी? Probabilities में सोचो. सारे add हो गए. So 1 होगी. You are saying probability X is less or equal to 4. Now if you look at the setup, it says X is always less or equal to 4, right? आगे तो है ही ना value 4.1 या 5 कुछ भी नहीं. So the last value of F is always 1 और फिर मज़ीद नहीं बढ़ती. Okay? You can ask us to calculate F5. Okay? It's not forbidden. But what will happen? उससे आगे F5 0, F6 0, तो zeros ऐड होते रहेंगे तो 1 से ऊपर वो ग्रो ही नहीं करेगा, right? And it can never go down. So F2 will always be greater or equal to F0. Okay, because either you add a positive probability or you add 0. You cannot add a negative value here. Yes? So that's why we say the cumulative distribution function is non-decreasing. It either goes up or stays at a value, then goes up, and then its ceiling is 1. After that it stops. No more growing, no more dropping. Okay. Yeah, so what's this saying? You will notice that as we advance in probability, the problems become more rigorous. Mathematics ज़्यादा होता जाता है. जबकि जो पिछली problems थी याद है वो बैग में से निकाला, उसमें वो जो descriptions हैं they are at play. Yeah. But later on it's mostly already दिया हुआ सब कुछ. All you have to do is do the maths. Right? Becomes more rigorous. So आपको दोनों चीज़ें चाहिए. कुछ questions के लिए, कुछ parts के लिए weight चाहिए, कुछ के लिए दूसरा. So there is a chemical reaction. There is temperature में error has C degrees for a controlled laboratory experiment is a continuous random variable X having the probability estimate. So they already told you it's a continuous random variable X. ये क्या दिया उन्होंने उसका probability density function PDF. It's saying okay between -1 and 2 this it follows this formula and all other values are 0. Yeah. So then verify that fx is a density function. So yaad hai density functions had to satisfy some conditions. Kya thi? Third wali to simply it says that it shows a probability. We don't need to check that. First two are the ones we normally check. Kya thi?
probability greater than 1
Yeah, so वो तो होगा ना probability का function की तरह मिलता है. This function can it have a value at any given x greater than 1 or can it have a value or it can have a value can it have a value less than 0. पहली ये condition ये थी if you remember that it cannot be negative. Yes. दूसरी क्या थी? Total area under this thing क्या होना चाहिए? it represent total area क्या represent करेगा? Probability of random variable x taking any value, right? That has to be 1, right? So these are the two conditions we normally need to check to see. So fx greater or equal to 0 and the total area under fx has to be 1. So look at this. Can this ever be negative? Square है और ये range है इधर कोई complex value नहीं है इधर, yeah? So it can never be negative, so that is satisfied. What about the second condition? The second condition says that the area under the distribution should always be 1. Discrete case में क्या था ये? Summation, yeah? Summation fxi should be 1 over all xi. So that means you have to do minus infinity. Now इतना तो आता आपको basic integration, yeah? Minus infinity to infinity, but we know that this function exists only in -1 to 2. बाकी points पे and non-zero only in this range. बाकी 0 है तो we don't need to do the whole thing. We can restrict ourselves to this minus infinity to -1 का क्या हुआ? Function वहाँ 0 है. We know the area is 0. Why bother? Yes. Similarly, what happened to 2 to infinity? 0. So just restrict yourself to this, and then ask yourself, okay, x square over 3 dx. Integral xn, now the xn plus 1 over n plus 1. Yeah. So वो आप use करेंगे वो simple सा integral है, and you will solve it, put the limits, and if that turns out to be 1, then this is a valid. If these two conditions are met, this is a valid PDF. Yes. अगर ये fail हो जाए तो फिर this function or the formula cannot represent a probability density function, right? ये उसके लायक नहीं है क्योंकि then it has properties which will violate the basic rules of probability. The axioms of probability violate हो जाते हैं. Right. दूसरा मैंने क्या पूछा? Probability between 0 and 1. Yeah. So again, कैसे हो गई? So you integrate. Always remember this. The density function, whatever it is, yeah, fx, it is representing the relative likelihood, yeah. इसकी जो भी range है, whatever range it lies in that range the total area has to be 1. It should never go below 0. That was the condition. And if you are interested in finding the probability in a certain range from say A to B, then that should be the area under this function in A to B. That's it. यही है ना इसका concept. Density है तो उसकी आप जितना volume आपको चाहिए, जितना area चाहिए वो निकालते जाओ. So you will redo this thing, but with what? To find this? With the limits changed. That's all. Right? So the limits are now 0 to 1. Okay. So 0 to 1, and that gives you probability x is between 0 and 1. By the way, what would be if I remove this equal here? I say x is strictly less than 1. फिर क्या होगा?
It is 0. Area.
So the question is, what would be the probability x is between 0 and 1? Here it's saying 0 and less or equal to 1. Yes? So क्या होगा इस केस में? अब वो पढ़ते हैं ना वो
डिफाइन नहीं है ना से
क्या है?
रेंज से डिफाइन नहीं हुआ तो ये
कंटिन्यूअस केस है ना. डिस्क्रीट केस में इसका जवाब डिफरेंट होगा इस बात का. ठीक है? Continuous में different. Continuous is dealing with integrals. yes, and continuous density function. Remember I said that in a continuous case the probability of any given point is what? Probability x equals 1 is what? 0. So it doesn't matter then. Less or equal to 1 and less than 1 are the same thing. So here this is a result of continuity. Yes, area में आप नहीं करते ना distinguish. So this was just a check to see if you remember. You could do it, look at it rigorously also. अगर आपकी integration या calculus strong है, you can prove that this less or equal to this, basically the two will be the same. Okay, so ये हो नहीं गया? No, okay. We have to find now capital F. पिछले examples जो थी they were for discrete case. Yeah. So now we repeated that for continuous case. So what is it fx in the continuous case? Capital Fx, the cumulative. Okay, this will be hard to see. Anyway, fx. Now, for continuous case, as long as probability, as far as probability definition goes, capital Fx has the same meaning. Yeah, its probability, this continuous random variable takes a value less or equal to x. Like f5 will mean probability x is less or equal to 5. Yeah, but in terms of small fx, I told you, remember, discrete से जब हम continuous में जाएंगे तो summations will be replaced with integrals. Yes, so क्या होगा ये? It is the area under fx. Discrete में क्या था ये? Fx was the summation of fxi for xi less or equal to x. ऐसे है discrete में. Continuous में, and we saw that for f0, f1, f2, f3, so on. Capital F0 was this thing, capital F1 was this whole thing. अब इसी को आप imagine करें continuous में, so it turns into a matter of areas, right? Instead of adding terms, you are adding infinitesimal areas. Continuous sum हो जाता है, yeah? So this is what you are doing. आप कोई मुझे बता दें इसकी limits. Sorry, lower limit तो easy है ना? कहाँ से शुरू करेंगे? इस केस में तो है जो ये general minus infinity. Yeah, it says xi less or equal to x. Doesn't say how less. Yeah, so this also includes from left hand side to up to x. So minus infinity to small x. Now this would make problems mathematically. एक x उधर भी है इधर भी है, so we are forced to replace this by some other variable. Let's say d ये dummy होता है ना इसके अंदर, doesn't matter. So doesn't matter as long as it's not in the limit. Yeah. So f nu d nu, that is your. So इसको कर सकते हैं आप इस तरह. Yeah. It's just you will integrate. For this case क्या हो जाते हैं limits? -1 to 2x square over 3. Sorry, it has to be fx, so it has to be -1 to x, and then you can make it maybe u square du. Generic banana. Yeah, so we're not integrating over the whole area. You want fx -1 to x. Why not minus infinity to x? We know 0 है वहाँ पे, so why not start here? It's a very simple integral. Integral xn क्या होता है? xn plus 1 over n plus 1, right? वो formula लगाएंगे and put x and -1 as the limits, and we will get, let's see what we get. Yeah, these are the formulas. Minus infinity to x f t dt. Probability x is between a and b. It's easy to see that it is fb minus fa. Okay, why is that? Let's say for the continuous case even. Let's see. let's say here we are assuming b is greater than a. Okay? Otherwise, so possible. So let's say a is here and b is here. Okay, and what's the probability that the random variable x lies between a and b? कौन सा area? This area. Yes. This is probability x lies between a and b. Now, what's this saying? Then it can also be calculated from the cumulative fb minus fa. How is that? Does that make sense? Let's see. What is fa in this case? कौन सा area? Minus infinity to a. यहाँ तो 0 है, so I don't need to draw. So fa is this area, isn't it? Yeah. What about fb? What's that? Minus infinity to b. That would be. Let's take that still another color. That would be this whole area. Agreed? ऐसे ही है. अब green में से yellow minus करें तो क्या बचे? Green में से yellow, green area जो green hash है ना, उसमें से yellow minus करें तो A2 भी बचता है. So this formula makes sense, right? So it's not magical. And a direct consequence of this is if fx is an integral of small f, then small f has to be a derivative of capital X. So in this problem we won't use it, but I wanted to put it here because it's good to have in mind. So anyway, you were asked to find fx. You were asked to find fx and use it to evaluate this probability. Okay, you say fine. I know that it has to be the integral from minus infinity to x. Do that. T square over 3 will become t cube over 9 minus 1 to x. Put the limits, and you get the other function, which is pdf. So you extracted or you did the CDF. So you got the cumulative from the PDF, and there it is. This is important. It says fx is 0 for x less than to minus 1. That makes sense. Between minus 1 and 2 it is x cube, this thing what you calculated. But we know that after the upper end of the limit, the area should be 1. Right? So it's important not to put a 0 here. Yeah? It's different from small fx. As far as this goes, we already saw that. So it can be f1 minus f0. You have that function, put 1 here and put 0 here and get the values, and you get your answer, right, to this problem. I think this is one of the last ones, so hopefully, yeah, let's make it the last. A privately owned business operates both a drive-in facility and a walk-in facility. On a randomly selected day, let x and y be the proportions of the time that driving and walking will be. Now these are such and such. So this is showing the proportions of on any given day, randomly selected day, and how many people use the driving, what percentage use the driving in that case. So if x is 70, y is 30, that means on that particular day 70% people used driving and 30% people used walking. So they have calculated some joint distribution, or in this case density function. There is this is continuous here. proportion निकाली है ना मैंने, so they are showing it like that. Verify condition 2. Yeah. So one of the conditions again this has to satisfy is firstly that it has to be non-negative. Yeah. Second condition for joint is what? The total area under this guy has to be 1. Okay. So how would you calculate the total area under a two-dimensional function? अभी तक तो हम single dimensional draw कर रहे हैं. Now you have a sheet. Yeah. So volume बन जाएगा. Yeah. So for volume you need कितने integral चाहिए थे? Double integral. Yeah. The integral will take its ranges from the two variables in there, x and y. So basically they are saying, they are asking you to verify that okay, at minus infinity to infinity and minus infinity to infinity, fxy dx dy equals 1. That is one property this joint distribution has to follow. In this case क्या हो जाएगा, x की लिमिट्स क्या हो जाएंगी? 0 to 1. Y की लिमिट्स भी 0 to 1. Proportion है ना, so they have made it. One is 100% people use this thing and so on. So you will do that. इसको आप सॉल्व करेंगे. डबल इंटीग्रल थोड़ा बहुत आता है सॉल्व करना, नॉट वेरी एडवांस्ड, बहुत बेसिक्स है दिया हुआ. So you first solve one treating the other as a constant and put the limits. Then what you get, solve the remaining result. Right. So वो तो हो जाएगा. What about this? Find probability x y lies in a particular area. I showed you this when we did joint probability. It says okay, the area is such that x must be between 0 and half and y must be between quarter and half. So what's the probability that this is satisfied? इसमें क्या होता है? It's very simple. Limits change. That's all. Without this, we are talking about probability x y in all possible. Yeah. So you put minus infinities. But here we are talking about a particular range. So integral here will remain the same fxy. These limits instead of 0 to 1, 0 to 1, they will be 0 to half for x and quarter to half for y. Yeah. And yeah, so we have the formulas in your book also. We will use that, but they make sense to memorize something to खास उसकी जरूरत नहीं. So first part leads to 1, yes, good. Second part, just change the limits and redo what you did, solve it, and you get this thing. Okay. So that's it for today. If you have any questions, you can ask now or later. It's fine. Right?
last question that is upload session.